So this is the first video in the neural network visualized with Python and PyQt series. And I created a directory and I put a folder in there called ANN for Artificial Neural Network and 4 Python files in that folder: the controller, the net, the layer, and the neuron. So I'm going to do the imports to the controller now. I don't know exactly what I'll need, but I'll start here. And we're going to use some PyQt files. Everything from core, everything from widgets, and everything from the GUI. So yeah, I called this file the controller, but these imports are more like viewer type imports. But in this program, the controller is going to play the part of the GUI, the viewer as well. And the controller is also going to take the net class from the net file, which we'll write soon. And now we're pretty much done for now. And as you can notice, I did not import an external library such as TensorFlow, scikit-learn, or NumPy. And that is kind of the point of this program, to force us to write everything from scratch and get this fundamental understanding of what's going on, so that later when we want to use a real neural network library such as TensorFlow, that will feel more secure about what's going on under the hood and can trust the solutions more. So we'll begin by throwing up a window, but before we can do that, we have to declare the net so that the import doesn't fail. So I go into the net class and do that, and now I can start writing the controller class. And it's going to inherit everything from QMain window. And then I write the initialization method here. And then we'll have to write some kind of main method here. We'll create an instance of the application. We'll create an instance of the controller. We'll print end of file so that we know that we've reached the end of the file. And we'll exit the application after we're done. So we got our window. So now that we have drawn the window, we're going to change the window so that it looks more like the finished network, something like this. And the first thing we're going to do is draw the neurons, which are these round rings, so that we'll get something that looks like this. So the coordinates of the circles in the picture are going to be taken from actual neurons. And the neurons are going to be in the layer class. So let's create the layer class. We're going to have a list of neurons in the layer class. And we're also going to have a add method here. It's going to take in a neuron object, and we're going to append the neuron to the list. This can probably be done without this add method, but it's good to have it. And we're also going to write a representation method right here of the layer. layer. So we're just gonna print out the layer as easy as possible. So that's our layer class. So now let's create the neuron class. So we're going to take in a few parameters here. We're going to have an index. We're going to have coordinates. And it's kind of questionable whether we should actually have coordinates here because they are obviously GUI related. But, well, they have to be somewhere. So might as well have them here. Input n. This is the input into the neuron, which is a double. And we're going to have an output, which is also in double. We're gonna initialize the variables here. And we're gonna have a representation. With the index in this form. And then we have to write format. The reason we write input n is because it was complaining that it was the input syntax was used before. And now it's actually complaining that there's a typo, but yeah, I'd rather have it complain about that than it using the same name as somewhere else. And that should be it. So now that we have neurons and layers, let's start making the net. So first of all, we're going to import what we need. This imports the classes. And since we're not inheriting anything, we can take that away. Or at least that's how I think it is. Define init super. So we're going to have a list of layers here. And then we're going to initialize this list using a method. So now we're gonna append a layer into the list of layers. And then we're gonna fill up this layer with neurons. So we got the index, we got the x coordinate, the y coordinate, we got the input, and the output. And now we're just going to do this for all the neurons we need. So this is going to be number 1. As you've noticed, we start with index 0 in this program. And we're also going to add a bias neuron into the first layer. We're not going to do anything with it, but it is there, and we should acknowledge that it is there. Is neuron. Yeah. So that's gonna have index 2, y coordinate 425. And now we're going to do the same for layer 2. We're going to create a layer first. And then we're going to put neurons onto the layer. Neuron. So we have to increase the x coordinates here. And then repeat this one. Five times, because we're going to use the bias neuron here as well. And then we're going to do the same for the last layer. Okay, now we have initialized our net. We're also going to write some get and set methods here so that the GUI window can get values from individual neurons and layers to update the window. So if we want to get a specific neuron, we're going to write in a layer index and a neuron index. Get neuron from layer. And I actually haven't written this method yet, so I'm gonna do it right now. There's probably a built-in method that can do this exact thing in Python, but I'm not sure how to do it, so I'll just write my own here. So we go back into layers, and we're gonna add this method right here. Get neuron from layer. and it's going to take in an index. That's it. Return self neurons. Add a certain index. Then we want a method that gets the coordinate of a certain neuron. Coordinate. And here we can use a built-in method without a problem. We get attribute, and it's going to take this neuron object we put in, and then we're going to search for the attribute with this name, coordinates, because that's what we call. Actually, we can rename these to coordinates midpoint, because that's really what it is in the neuron class. Then we want a set input method so that we can change the inputs. So input to a neuron, and then we're gonna set attribute of this neuron. We're gonna find the one with the name input n, and we're gonna update with the new value. We want to be able to get an input from a neuron. And here, because we're not entirely sure what type it is, but we want floats, so we're gonna make extra sure that it comes as a float, because it might be stored as a string here. But we want to be able to set an output. Of a neuron with a new output. And here we can just write set attribute neuron output, and we're going to change it with a new output. And finally, we're going to have a a get output method here. And since we also here don't know what type it is, we're going to make sure that it comes as a float. So that's our get and set methods. Let's see if we can create a net and get a neuron from this net. Let's go back into the controller. Let's create a net instance. And then let's create a temporary neuron here. So we're going to take the very first neuron in the very first layer. And then we're going to test the representation method here in the neurons to see if that one works. So that now that when we just want to print the neuron, it's actually going to go into this representation method and print it out, hopefully. Let's see if this works. So we see the Windows printer here. and the neuron is printed out like this with the coordinates, the index, the inputs and outputs. So now that we have the network, let's try and draw it. I can take away this temporary stuff first. So we can begin by changing the geometry of the window, and you might want to change these parameters to fit your desktop or whatever. I will use these parameters right here. Or actually, since this window is going to be static, it's not going to be changeable. You might actually want to use these parameters. And then we're going to write the paint event method, which is like the paint message loop in Python. So this is used for everything that's going to have like painting in it. QPainter. So we create this painting instance here. And now we're going to draw the neurons. So we're going to create this method here, neurons. And we're going to insert the QPainter instance into there. And when we're done drawing, we're going to end here. So let's write the draw neurons method. We're going to create a pen. Going to make it black with size 2, and we're going to make it into a solid line. We're going to make sure that the QPainter instance is using this pen. And now let's do the drawing, and I'm just going to brute force this drawing, so I'm just going to draw one layer at a time pretty much. With a simple for loop. Since we have 3 neurons that we want to draw, including the bias neuron, in the first layer we're just going to run this 3 times. So we're going to take the instance of the net, and we're going to get the coordinates, midpoint, and in order to get the coordinates, you see here we need a neuron. So we're going to use the same instance to get a neuron, and we're going to take it from index I here. And yeah, this is probably not the most beautiful way of doing it, but anyway, it works. So yeah, we can do that. And then we're going to take the coordinate, and we're going to draw an ellipse based on the coordinates, and yeah, we start by decrementing the x coordinate with 25 pixels, and then doing the same with the y coordinates, and then we're gonna have width 50 and height 50. So that was for the first layer, and then let's do the exact same thing for the second layer. In this layer we're going to have 5 neurons, and yeah, this is from layer 1, so you have to write a 1 there. And then let's do the exact same thing for the third layer. Which only has 2 neurons including the bias. And we're gonna put that one here. So let's see if it works. Yes, it does. So this is how the window is gonna look. Let's now create the synapses that will connect these neurons. We'll create this class in the same file as the net class, because this class is going to be so small. So we're going to initialize the synapse with a weight and a pointer to the neuron on the left and a pointer to the neuron on the right. We're also going to have a delta weight variable here, which is like the difference in the weights. We'll talk about that later, and for now we're going to initialize it to none. We're also going to create a representation method here for debugging purposes. I'm just going to copy it in here from somewhere else, but feel free to write it down, because it's pretty good to have if you're going to check this stuff out. Now that we have the synapse class ready, we need to create some containers for these synapses in the actual network, so that we can access the synapses and do operations on them, like get their values or set their values. We're going to have one such between layer 0 and layer 1. That's for the L0 layer 1. And we're using sets here instead of lists. We could probably use lists just as well, but I'm using sets here because the synapses are going to use two indexes to be identified, like the neuron on the left and the neuron on the right, instead of just one index. And I feel more comfortable doing this kind of identification using sets instead of lists. And then we're also going to set a initial value for the weights. And this could really be anything between yeah, I think anything between 0 and 1 makes sense. Perhaps it could be between -1 and or something else. I'm going to use 0.125, but really it doesn't matter, and this is actually giving me a random number later. So now we can build the synapses, and we're going to do that using a method, build all synapses. And we'll put that method like down here. So we start by building the synapses between layer 0 and layer 1. And we're gonna run through the first layer here, which has 2 neurons. Note here that we skipped the bias neuron. We might do operations on it later, but for now we're not going to do it. So note that get neuron. So this is the pointer to the left neuron, and then we run through the right neurons. There's 4 of them without the bias neuron. So it's from the first layer and index J, and then we can actually create the synapse here, and we're gonna put it into index IJ, into the set that we created above. We're gonna set its weight to initial weight values. We're gonna have a pointer to the left neuron and a pointer to the right neuron. And then we're gonna do the exact same thing for the other set of synapses that we created. So in that set we have 4 neurons in the in the left layer, and this is going to be LNL1. This is on layer 1, and there's only one neuron in the other, the last layer, because we skipped the bias neuron. And oh yeah, wait, this is going to be 2 here, and 1 and 2 here. So now we have the synapses, but we haven't actually drawn anything, and our net still looks like this. When we want it to look more like this, with all the lines and the text boxes. So let's go about and draw some of these things. We'll start by doing the text boxes, or Q line edits as they're called. And they have to be in this class I call the controller. This should actually be called controller and viewer, because all the GUI related stuff is being done here. So there are 2 inputs. There are 2 outputs. I'll just put them in a list because it's pretty easy to do that. We're gonna have the sum of the weights, which is just gonna be one value, so we might initialize it straight away to a Q line edit. And these lists are also gonna be filled with Q line edits. And then we have the weights, which is a set between layer 0 and layer 1. And yeah, again, like you might think now that we're recreating everything again, but this is GUI stuff, and it has nothing to do with the objects that are up here. I mean, these are the real objects, and we're just trying to recreate the data in these objects using these Q line edits. So yeah, don't be fooled by that. This is GUI stuff. I'll probably have to make a bunch of more of these later. Now I'm just using what I got so far. So this is the expected value. Error. And then we're gonna make a method that puts Q-line edits into all these lists that are now empty. And notice here that I call it draw line edits. But I do not call this method from inside the paint event because we're not using an actual painter. We don't need to do it from within this method. That is because we only use this method to initialize the line edits, and later we'll write a method inside the paint event that will be used to update the line edits. So let's do this method now. So we'll collapse this one, and then we'll do this method right down here and draw edits. Zero to 2, so 2 neurons. Without the bias neuron, we get the coordinate. Of the neuron, because that we have to use that to actually like draw the line edit. Or I mean, we could do it without, but this one works as well. We create a local handle to this, or no, yeah, we create the object here. QLine edit. Then we're going to set the geometry using the coordinates. I guess, like, if this was a serious or a professional thing, we would use the designer to do this. But then you have to like convert it from a UI file to a Python file and all that. So I'll just, yeah, I'll do it the hard way, the old and hard way. Yeah, so we got some coordinates, and then we finished the QLine edit. So now we append it into the list. And I don't just like make this stuff up on the go. I actually tried this, so I kind of know what the values need to be here to work for this GUI that I made. And then we're gonna make the weights. set the geometry of those using the coordinates as well. And they're gonna be like in front or behind the other ones, depending on how you see it. And here we have 4 weights, so we're gonna run this through the loop here, and yeah, trial and error resulted in this 22 here. 20. And now we're ready to put this stuff into the set. Oh yeah, I have to, oh sorry, this has to be a J here, of course, because this is a nested loop inside here.